All right, today we're going to be talking about what's called complex numbers. And in order to talk about complex numbers, we will need to talk about what an imaginary number is. So we're going to have imaginary numbers, that's our first section, and then the second one is complex numbers. So we're going to be able to do both of those today in this section. So let's talk about what they are. So the letter I is a number, which when multiplied by itself will give us the value of -1. This means that I equals the square root of -1. This is actually very important for us in terms of math that we are trying to do. It becomes very useful in finding the square root of real negative numbers. For example, we normally cannot find the square root of -16. But using imaginary numbers, we can say the answer is 4i, because the square root of 16 is 4, and the square root of the -1 is just I. We understand that imaginary numbers result as 4 times the square root of -1. Is how we would go ahead and say that. So what is a complex number? A complex number is any number that can be written in the is kind of cut off here, the form a plus bi, where a and b are real numbers and I is the imaginary part. So you have 5 plus 2i, or 1 minus 3i, or 1 plus a -3i. Either way you want to write that. But it has that I in there. That's what a complex number is. It has two parts, not just the I. But this whole I idea allows us to take the square root of negative numbers. We haven't been able to do that so far. It'll become very important as we build up to the fundamental theorem of algebra, which is what our end goal of this, not necessarily this chapter, but this whole first semester kind of deal. All right, so let's see how we use that. All right, so they want us to simplify the square root of -50. So we're going to birthday cake. Now I did it upside down. I think it's easier to do it upside down just because then you don't have to put a lot of extra space. But if you want to do it right side up, that's fine. So we have 50, and 50 divided by 2 is 25, and divided by 5 is 5, and divided by 5 is 1, that cake here, right? So -50 is -1 times 2 times 5 times 5. Now remember, when we're simplifying radicals, we're looking for pairs. So I want a pair. I got a pair of 5s. The pair of 5s here then come out in front. The -1 becomes an I, and the 2 has no friends, so it stays inside the square root. So it's 5i square root of 2, and that's my answer. Let's try another one. So here's the square root of -28. So we have 28 divided by 2 is 14, divided by 2 is 7, divided by 7 is 1. Now, my first thought with 28 was I was going to divide it by 4, but I can't do 4 because 4 isn't a prime number. So I had to go back to 2, and then 2 again, and so on and so forth. Now I write it all out. I have -1, 2, 2, and 7. The 2 is a pair, so that's going to come out in front. The 7 doesn't have a friend, so it stays inside. And the -1 becomes an I. So I have 2i square root of 7. One more. 32. Again, I got to start off with my 2. It's even, so I divide by 2, and then 16, then 8, then they're all 2s. So now I have 2 pairs of 2s. So when I have pairs of 2s, I'm going to multiply them together. So a pair of 2 is 4. So I'm going to have 4 coming out. I have 1, 2 left over because these paired up and these paired up, and I have 1 left over, and a -1. So I have 4i square root of 2. All right, so we can even multiply these together. So how do I multiply these together? I multiply the parts in front, so -3 times 2, and then the i's together. -3 times 2 is -6, and then it's I squared. I times I is I squared. Now, I squared is special because I squared is always -1. That's what we defined it as at the beginning. So anytime we get an I squared, we can actually rewrite that. And notice I rewrite the I squared as -1. So this just becomes -6 times -1, or just 6. So my answer is just 6. So I can go ahead and multiply these together and just get 6. All right, let's try another one. So 3 times 5 is 15. I squared, that I squared becomes -1. So 15 times -1 is just -15. All right, so we can even use this to solve some basic equations. So I have 5y squared plus 20 equals 0. I can get the y squared by itself, so I move the 20 over. So it's 5y equals -20 divide by 5, and y squared equals negative 4. And now I can take the square root of both sides, and I can take the square root of 4, it's 2, but the negative makes it 2i. So that's my answer, plus or minus 2i. And I can do it again. If it's a 50, I can move the 50 over, divide by 2 is negative 25, square root of negative 25 is 5i. Really simple, those problems. All right, we can even take a look at complex numbers. And the complex part and the real part have to stay the same. So this 2x has to equal the negative 14, and the y has to equal that negative 3. And so those different parts have to stay separated. The imaginary part stays imaginary, and the real part stays real. So the number part here, we can go ahead and set them equal. 2x equals negative 14, so x equals negative 7. And then the y becomes just negative 3. In order for it to stay equal, to equal out. So we can do that again. Here we have 3x equaling 15, so x is 5. And here that's 2, so this has to be negative 2. All right, what does it mean to add or subtract complex numbers? Well, again, I want to keep them separated. So I'm going to keep the real parts, the 3 and the 2. We're going to add those together, and we'll get 5. And the 5i and the negative 4i, I put together, and 5 minus 4 is just 1i. So I just wrote I instead of 1i. It's just easier. So adding and subtracting are real easy. You just take the different parts and put them together. So let's try a subtraction. So it's 4 minus 3, which is 1. And then we have negative 6 minus a negative 7. Be careful with the double negative. So that's going to be 1i. So 1 plus 1i, or just 1 plus I. All right, we can even multiply them together. Now you can multiply them either with FOIL or with a Punnett square. Both work. So here's 1 and negative 3i on the side here, and here's 3 plus 2i over here. So top left is 3, top right is 2i, then negative 9i and negative 6i, so I wrote them all out. Now remember, the I squared is negative 1, so I should never have an I squared in my answer. So negative 1 times that negative 6 is positive 6. And I can add that to the 3 and get 9. So 9 minus 7i, the 2 minus 9i is the negative 7i, and that's my answer. So let's multiply it out here using FOIL, in case you want to do that. Firsts, and then outers, then inners, and then lasts. So we wrote them all out, put them together, and we get that I squared again. And that I squared, remember, is going to be a negative 1, so this is going to be a positive 24. So there's that negative 1. Make it a positive 24 plus the 3 is 27. The 12 and negative 6 is 6i. So that's my answer. We can even divide them. Now dividing is a little more difficult. We have to use something that's called a complex conjugate. It's a really big word, but what does it mean? Look at the denominator here, 3 plus 2i. What I need to multiply both top and bottom, because remember, it is a fraction, and whatever we do to the bottom, we got to do to the top. I'm sure you've learned that before. I'm going to write the inverse of it, or the opposite of this. So see how this is 3 plus 2i? I'm going to multiply by 3 minus 2i. It's always the opposite sign. So if this was minus, then I'd do a plus, if it, whichever. So notice here, it's going to be 3 minus 2i. Those are considered conjugates. That's where that word comes from. And they're complex conjugates because they're complex numbers. So 3 plus 2i and 3 minus 2i. We're going to put those together, and then I got to do the same to the top. Now, the numerator here, I'm going to have to go ahead and distribute this and simplify. The denominator, unfortunately, is a Punnett square. Now, it is a specifically set up Punnett square, because to simplify this, we don't want this I in the denominator. It's officially a square root, and you can never have square roots in the denominator. So we want to get rid of it. All right, so let's do the distributing up top. 5i times 3 is 15i, and 5i times negative 2 is negative 10i squared. Now the bottom is actually the difference of squares. We set it up that way. So when you do the Punnett square, the bottom left and the top right will actually cancel out. So you're going to get 9, and in the bottom right, you're going to get negative 2i squared. But Mr. Bailey, you said you can't have any i's in the denominator. You're right. But remember, I squared can be rewritten. I squareds can be rewritten as negative 1. And when I rewrite them as negative 1, there is going to be no i's left in the denominator. So negative 1 here. So this is positive 4. 9 plus 4 is 13. We have the 5i, and then this becomes positive 10. Now, I don't like the way that says it. We should be 10 plus 15i. So they went ahead and rewrote it that way. Now, they separated the 13, so it's 10 13 over 15 13s. If you want to leave it all as 1, 10 plus 15i over 13, I would accept either answer. But they do tend to write it this way, just to kind of enforce that a plus bi form. But I would take it either way. All right, look at this one. Notice this one does not have a plus or a minus in the denominator. This one's actually a little bit easier because of that. If I go back to this one, notice that we had that plus in there. So we had to do this whole conjugate thing, which made it a much longer problem. This one, we only have to multiply by I, because I need to get that I squared. Now, if I multiply by I, I'm going to have to distribute here. I get 5i plus I squared and just 2 times I squared. Now, those I squareds become negative 1s. So that's negative 2 and negative 1 on top. And writing it a little bit better, that becomes 1/2, and this is negative 5/2 I. So that's our answer. And that's what I have for you today.